Someone sent me this email and I thought a video would just be the easiest way to explain it. Before we consider the average speed, let's just consider the distance. It says it's measured to the nearest mile, so this is actually an average. It could actually be a little less or a little more, and then it's rounded towards 40 miles. So what's the lowest possible value that it could be so that it would round to 40? Or the highest possible value that it would round to 40? Because this says nearest mile, this part is quite easy. If it was something else, it would be more difficult. But what you do is this error interval, this is what the error interval is, divided by 2. It gives you the value that you have to add or subtract to the average to get these bounds. So if it was just, we didn't consider the error interval at all, just it was normal numbers, and we say integers, it would have to be something 0.5 to be rounded up. So 40.5 would round up to 41. And in this case, the error interval divided by 2, this gives you the lower and the upper bounds. Because it's anyway the nearest mile, we're working with integers in this question, this is actually the same. But if it wasn't integers, you would use this. So the lower limit is the smallest value that would round up to the estimate. In this case, when you get to something 0.5, it rounds up. And the upper limit is the smallest value that would round up to the next estimated value. In this case, it's this. So when you see that you take the error interval divided by 2, if you add and subtract it, you get the upper and the lower bounds. And if it would be minutes, it would be the exact same thing. The upper bound, because it's again the nearest minute, it's 1 divided by 2 gives you 0.5. It's 30.5 and 29.5. These are your upper and lower limits. And if you would want to write it as an inequality with these symbols, it would be like this. You include the lower bound because once it reaches this, it would be rounded towards that number. By the way, this represents the error interval. It would be rounded towards that number because that's when it reaches the point where you round it upwards. But you don't include the equal part here because everything just until just before this would be still rounded to 40. But once you reach this number, it rounds upwards. That's why you don't include the equal sign. So now to do the actual question. I haven't actually done this topic in school, but I've identified a method that would work. So you have the upper and lower bounds for these, right? So let's first do part A. The greatest possible average speed of the car. So we would use the upper bounds of both because you're going to do distance divided by time. So the greatest average speed would be 40.5 divided by 30.5 if you want it in miles per minute. If you want it in miles per minute. If you want it in miles per hour, you would first have to convert this to hours, which you do with, then you have it in miles per hour, right? And the same thing here. Least possible average speed of the car would be the lower limit, which is 39.5 divided by 29.5. Then you get the answer in miles per minute. Or if you want it in miles per hour, divide this value by 60 as well. And then you get the, let me just say, you get the hour value. And then you would have to do, I'm just writing it properly, sorry. So I'm not going to calculate this exactly, but this at least shows you the method of how to do it. Another method which I've also identified is you could find the average speed, which is just 40 divided by 30. Then you would get the answer in miles per minute. Again, I don't know what unit they want. Let's say it was in miles per hour. This would be easier to calculate in my head. then you would have to find the error interval in miles per hour, because then you would have to do 1 mile divided by 1 minute. Then the error interval would be 1 mile per minute. That would be easier to calculate than first converting this into hours. Then you would do the same thing you did before. The error interval divided by 2 plus that value would give you the highest average speed, and minus that value would give you the lowest average speed. So to clarify what I mean, when you do 1 mile divided by 60th of an hour, that's 1 minute, right? This will give you a value in miles per hour. That value divided by 2, that's what you have to plus to get the highest possible average, and to minus to get the lowest possible average speed of the car. I hope this has helped. I have never done this topic in my life because I'm in an IB school, not GCSE. I think I explained it correctly. I hope this helps.